First things first, a distance x of a particle is fixed by a point O is given by the equation x equals a is the amplitude, sine omega t plus e, where e is like a phase constant. Show that it will undergo simple harmonic motion. So, x equals a sine omega t plus e. Now, what you do next is you do your velocity. Your velocity is dx dt. You differentiate with respect to t. The first thing you can be guaranteed is that the sine turns into a cos. The angle is maintained. It's the second thing. Third thing is whatever is in front of it stays where it was. And then finally the last thing is differentiate the angle with respect to t. And when you differentiate the angle, you get omega. Is that right? Differentiate again to get acceleration. Remember, when you're proving simple harmonic motion, it's a equals minus omega squared x is what we're looking to do. Differentiate one more time. Once again, the a and the w are considered constants. They'll go straight down. The cos will change into a minus sine. The angle is maintained because the angle never changes during differentiation or integration. Now what happens after that, however, is you do have to still differentiate the angle. Differentiate wt plus e with respect to t, and what you get? Another w. Acceleration, therefore, now what they're sort of going to get mixed up with is, see the way they keep using the small a, and it's a bit confusing. What you could do is you could go back and you could specify that capital A is the amplitude, and that you're using small a for the acceleration. So we're going to get minus a omega squared sine wt plus e. Now we still haven't proved that the acceleration is in a different direction to the displacement, so we have to find out a way to reintroduce x into this equation. X is a sine omega t plus e. There's your a, there's your sine omega t. So now we can replace that in and we get a equals minus omega squared x. Everybody alright with that? That's very standard. It's in a couple of different years. You'll see that type of question, okay? If you look at the original formula, Adam, top line, x equals a sine omega t plus e. And then what I'm basically doing is but look, I'm just gonna highlight the parts I need. I'm gonna use the a, and I'm gonna use the sine omega t. That's what I replace x with. And the minus omega squared is still there. Alright? Now, going to do next, guys, is this is a nice question here. Next question is a particle moving with simple harmonic motion starts t equals 0 from a point 1 meters from the center, x equals 1, with a speed of 9.6 and an acceleration value of 16. Now, where to even begin with this, okay? Acceleration equals what? Minus omega squared x. Now, please remember, they're talking, like, they don't have to specify that the acceleration is minus 16 or plus 16. We don't know yet. It could be, because remember, simple harmonic motion, remember I told you it's symmetrical. So, what I could say is that if the particle, as it's bobbing in and out of the amplitude like this, okay, I could say that at a certain point it's going 16 in this direction, and then when a similar particle reaches the same point going in the opposite direction, that can be going plus 16. They're simply referring to the magnitude. Is that alright? So, what I'm going to argue here is this, guys. We're going to have a, I'm not going to worry about the sign. So if I was to write down 16 equals minus omega squared 1, 16 equals minus omega squared, like, you're going to get a complex number there, aren't you? You're going to get w squared equals minus 16. And you know, look, we've never done complex numbers here before. The minus doesn't matter. Okay, so W equals 4. That's one thing off our list. We're looking for A, amplitude, I'll call it capital A, W and E. So we've got one of them off the list. Does it? Sweet. Read the question. Now, the next part is next part after that is we're gonna dial into velocity. Now, you'd have a couple of choices on your velocity, but you can see you can relate the velocity to time. So velocity and time equation. Do we have a velocity time equation here? Look at this line here from earlier. What's phi equal to? Phi equals A omega cos omega t plus E. Okay. If that's the case, then I should be able to use 9.6 being my velocity. 1 second. 9.6 being my velocity. W omega is 4, so it's 4A. Cos, what's the time this happens at? Omega is 4, isn't it? What's 4 times 0? Because the time is 0. It says it happens at a certain point. It begins. So t times 0 plus E. And now we're going to get I'm going to divide the 9.6 by 4. And I'm going to turn that into 2.4 equals A cos E. So A cos E, yeah? How many variables in that question? In that equation? 2 variables. So at the moment I can't really work too well with it, so I need to find another way. I need to find another equation. Well, I need to find another equation. Okay, so what I'm going to do next is I'm going to work with something else. So what I've worked with so far is I've worked with V, and I've also worked with T. Is there any way I can compare A and T together? A and T maybe? Or even, yeah, I've used A, haven't I? What about X and T as a combination? What about displacement related to time? What about X and T? There we go. X equals A sine omega t plus E. Fair enough. 1 meter. Amplitude, we haven't got a clue what it is. I know the time is 0, so 4 times 0 it's going to be 0. Epsilon. Yeah. Specifies it in the question 1. Part 1. Okay. Now, what we're going to get here is this. We're going to get I'm going to divide one of them by the other one. So I'm going to put 2.4 divided by 1, and then this is going to be A over sine E. Now I'm going to get 2.4 equals, the A's cancelled, don't they? And we get cos E over sine E. I'm going to turn them both upside down to get 1 over 2.4 equals sine E over cos E. Why did I do that? What am I trying to set up? Trying to set up tan E. Okay, so because sine E and cos E are tan E, I'm going to tan inverse that. And what am I going to tan inverse it? E equals, I think I have it here, equals 0.365. Just so you know, I put that into the calculator. That's also 5 over 12 equals tan E. So I decided to go off to the corner here, and then just call that E, call that 12, call that 5, then just do Pythagoras theorem to find out that's 13. You'll see I'll need that in a second. Okay. Now, I've now found out what E is. So I've found W and E, but what I haven't found out is the amplitude. Amplitude is the last thing I need to find out. So I look for an equation that has amplitude in it. This equation here will do. So amplitude equals 1 over sine E, and therefore sine E is 5 over 13. A equals 1 divided by 5 over 13. A equals 2.6 centimeters or meters. I can't remember. 2.6 meters. There you go. Okay. So look at this, guys, right? Very easy does this. It's moving in horizontal motion. Because it's horizontal motion, the force is up equals the force is down. That's brilliant. Now, second thing we're going to look at is centripetal acceleration. I have a choice, but it's specified angular velocity. So centripetal force equals mr omega squared. Now I need to fill in enough information to make this work. Okay, length L, isosceles triangle. Make up a letter for the angle. I'll call it alpha, and alpha again. Okay, next thing. 4 meters. Okay, that's grand. Find the value of W if the ratio in tensions of the two strings is 11:9. Now that's different. 11, a ratio of tensions. We haven't really seen anything like that before. So let's work with that. T1 is to T2 is 11:9. So in essence, 11T1 equals 9T2. Therefore, T1 equals 9 over 11. What's it? Did I change them all to T2s or T1s? I should change it to 11 T1s. Yeah, because T1's the smaller one. Sorry? So you guys just scratch that for 1 second. What we're going to do. Shh. Okay. So what basically we're going to be using here, guys, is T2 is 9/11ths of T1. Is everybody happy enough with that? Now, what we're going to do next is we're going to do force up equals force down, and I'm going to break up the tensions. So this is T1 here, and this is T2 down here. So T1 going upwards this direction, and then T2 going downwards in this direction here. Dot them up. Okay, so T2, that makes this, put a line here. Alpha is down here. So T2 cos alpha working its way up. Or sorry, its way down. And T2 sine alpha working to the left. Okay. Now this is the top angle. Sorry, got that one wrong there. That one's going. That's pulling upwards, and this one in here. Call that alpha as well. We're working on the top triangle. T1. That's T1 sine alpha, and on the other one is T1 cos alpha working up. And so for a horizontal motion question, you'll always work the forces up and down and left and right to the XY axis. Okay. Now that you have that done, what you're going to do is you'll separate them out into their two equations. I'm going to start up with forces up equals forces down. One thing I've forgotten in all this is the mass. mg working its way directly downwards. So what goes up equals what goes down. I can see T1 cos alpha holding us up. That's by the upper string, being weighed down by the weight and the tension in the lower string. I can then move it over one side. I'll do that now in a second. Move everything over. I'm going to get T1 bracket minus T2 cos alpha equals mg. I'm going to stop there because I know no better. Like I can't predict anything else that's going on at this point in time. Next, I go to my FC value. FC is centripetal acceleration. Centripetal acceleration is always directed back in towards the center. So we're in our case, we're looking for forces left. Okay? So what's going left? So what's going left is this. We have T1 sine alpha plus T2 sine alpha equals m r omega squared. Okay, so m r omega squared. Now, I'm dealing with a lot of variables, would you agree? There's a lot of different letters going on here. I have 3 of them in the first one and 3 of them in the second one. So, and I need to find a way, some sort of commonality to the system here, okay? So, what I'm going to do is, I'm going to change r. If I can change r into alpha somehow. So I'm going to go back to the top, and I'm going to look directly at r here. Okay? R is here, and L is here. This means sine alpha equals r over L. R equals L sine alpha. Okay, that's good news. Change the r to L sine alpha. And what happens to all the sine alphas? They cancelled. A particularly good call, okay? Now, T1 plus T2. The next thing we could do is we've already got our ratio nailed down from earlier, don't we? T2 equals 11 over 9 over 11 T1. So 9 over 11 T1, replace that for T2. And what does that give us next? That's another variable down. So we're going to have 20 T1 over 11 equals ml omega squared. T1 is going to be 11 ml omega squared all over 20. Everybody happy enough with that? Okay, I've worked that down to how many variables now? Still on 3, haven't I? I'm on L omega. Actually, the first one had 4. That T1, T2, L alpha omega. Actually, I had 5 to begin with, and now I'm down to 3. Okay, go over to the other side and have a look at this and go, okay, T1 minus T2 equals mg over cos alpha. Using my knowledge from earlier, I can change T2 to T1. Okay, that'll work. And the next thing I also have to change is mg over cos alpha. So cos alpha is an outlier between both equations, isn't it? See the way there's lots of T1s there, so it'll be 2 over 11 T1. And there's mg. The cos alpha is really hampering progress here because it's not compatible with the other equation. Go back to the very top again and go, okay, cos alpha. Can anybody tell me what distance it is from here to here? It's going to be 2. That would mean that cos alpha is 2 over L. Okay, that's much better. So cos alpha being 2 over L. So 2 11ths T1 mg divided by 2 over L. Dividing by 2 over L is the same thing as multiplying by L over 2. Now we're going to cross multiply up to 11. We're going to get 11 mgl, and we're going to get 4 on the bottom equals T1. We're now going to run both of these against each other. The two T1s are going to go head to head, and what's going to happen here is your 11s will cancel, your m will cancel, your l will cancel. You're going to get 20 over 4, which is 5g. Whoa. Wait. Oh yeah, 5g. Yeah, 5g is grand. Yeah, haven't made a mistake. 5g is 49. 5 times 9.8. Omega equals 7.